Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. I would like to say thank you for coming in my presentation. It's a great to see you all. My name is Dichi Syahbana. I am Department of Electrical Engineering, Faculty of Science and Technology, Al-Azhar University of Indonesia. The purpose of my presentation is to show you up about our research in telecommunication system with the title is an improved design of multiband patch antenna at 26 GHz for 5G mobile. Okay. First of all, this is introduction. I will let you to see about our research. We all know about in 80s decade. Born a telecommunication idea with the name is 1G, or we can call it first generation. There is analog voice, human to human, and it's early mobile phone. After 80s decade, we all know born again 2G as second generation, 3G as third generation, and now we experience the 4G. The fast network in our life. But if we go through the continue about development in telecommunication system, maybe in 2021 and 2022 we will experience the fifth generation. There is an interconnected device, or we can call it by IoT, sensor and system for consumer, governor, and business. Because of that, our research about telecommunication system, especially about microstrip antenna, can be involved as a pioneer to produce the frequency spectrum at the 5G. The second paragraph of introduction is this work will make design model and simulation that can be fulfill a good type of microstrip antenna at 5G multiband frequency from the coverage 22 gigahertz till 40 gigahertz with a conducting strip in a patch of microstrip with will be connect in which there is the type of fit technique. That is why our research choose the improved design because there have been no studies which compare to use of parametric element that make very significant change at high gain and can make multi-band frequency. Section 2 is coming from methods. We have 4 points. Number 1 is microstrip antenna is a metallic patch on a ground substrate. The model of microstrip antenna to construct the thin conductor patch place a small fraction of wavelength above a conducting ground plane. Number 2 is the technique of method in microstrip antenna that is called by microstrip line fit. There is an easy method to fabricate because it's a simple model to easy to match by controlling the inset position. So the microstrip line fit has advantage of using to feeding method. It's easy to fabricate, easy to match by controlling inset position, and easy to model. Also, it allows for planar feeding. We use material FR4 as a substrate of thickness 1.6 millimeter, and it has relative permittivity 4.4. And the last of this slide, The 3D design was developed by using software it called by CST Studio Suite to simulate our research. The proposed design was like this, and the optimized design were like this. Based on the design, microchip patch antenna using FR4 as a substrate. This is a 3D design developed just distribution, like last slide. But the performance and result, which are further detailed in the next table of this study, are keeping some parameter from the proposed design with our previous observation, which length and width of paths must not different. Before we optimize, the ground design was full cover, 100% of the substrate. But to improve the performance and result, it changed from some value like length of ground, width of ground, height of substrate, length of substrate, width substrate, height of paths, length of paths, width of paths, length of insert fit, gap fit length, length of fit. You can see the proposed and optimized difference of the design dimension of microchip antenna design. Now we talk about result and discussion. There is two results in two types. The first type is single band frequency. In a return loss, we got 26 gigahertz in a middle frequency, and the smaller minus 10 dB, which mean 90% successful power emitted, range at the design of the bandwidth is 23 till 27 gigahertz. It will be a good types of a single band. And also we go to VSWR from optimized antenna design. It's less than 2 for the resonant frequency, 1.0335 gigahertz. Yeah. This result clearly depict that the reflection and thus outstanding wave has been suppressed due to optimization using the microchip line method. Figure 6, it shows you to consider the patch antenna using microchip line fit, because the radiation from microchip antenna give us the result of total field gain is nearly 7.41 or 7.06 dB at 26 gigahertz, and shown by figure 6. And this 2D far field directivity. And the types of number 2 multiband frequency. The return loss is value less than 2, yeah, less than 2, with 1.0335 gigahertz. The result clearly depict that the reflection and thus outstanding, but divided by 3 frequency of band, lower, middle, and high. So from figure 5, it can be concluded that the design antenna at multiband into 3 types. We can see the result in result of inference of all types, but we like to show you up. This is the result of multiband frequency in return loss and PSWR. There is a good result in 5G mobile, and also this result surprising despite the fact of the range frequency met in from 22 till 40 gigahertz. From figure 11, the radiation from microchip patch antenna at multiband give the result of total field gain is 6.846 dB at 26 gigahertz, yeah, and has radiational efficiency minus 3.909 dB and the total of efficiency is minus 3917 dB. That is a 2D far field in figure 12. And now this is the result or inference of all types of value from a single band and multi-band antenna microstrip with a frequency range, with a larger bandwidth. We got total field gain, radiation efficiency, and total efficiency. Now we go to the last section, the conclusion. We got three conclusions in this work. Number one is this work that and the optimized modified model for multi-band high gain microstrip patch antenna. This is so possible to propose in a commercial deployment in Korea, Australia, and Finland. Number two, the coverage frequency with multiband confirm that at 22 gigahertz till 40 gigahertz and 25.96 gigahertz and 31.126 gigahertz and 37.221 gigahertz as a middle frequency or three types. The last conclusion is the maximum gain of this research is we got 6.85 dB, which is seen by the performance of the modified strip patch antenna with stimulated result. Maybe this work has opened several questions that need a further investigation. Further work need to be done to stabilize whether there is net precise gain return loss by minus 10 dB to produce the transfer power. Okay, that's all from me. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.